On April 18, 1955, the world lost one of its greatest minds when Albert Einstein passed away at Princeton Hospital. He had been hospitalized for an abdominal aortic aneurysm, and despite medical advice for surgery, Einstein refused, stating, "I want to go when I want. It is tasteless to prolong life artificially." Just hours after his death, pathologist Dr. Thomas Harvey performed an autopsy, not only to determine the cause of death, but also to fulfill a clandestine mission. Without permission from Einstein's family, Harvey removed Einstein's brain, hoping to uncover the secrets of his extraordinary intellect. This unauthorized act led to a decades-long journey for Einstein's brain, as Harvey transported it across the country, often storing it in unconventional places. Before delving into the scientific findings, let's address a persistent myth that Einstein was a poor student who struggled with mathematics. Historical records, including his actual report cards from the Swiss and German educational systems, clearly debunk this notion. In fact, Einstein excelled, particularly in science and mathematics, consistently receiving top grades throughout his schooling. Now, let's turn our attention to the actual scientific analysis of Einstein's brain, which began years after its removal. One of the most striking findings was an unusual pattern in his frontal lobe, specifically an extra gyrus in the right frontal lobe. This extra fold, or gyrus, could potentially have contributed to enhanced cognitive functions related to planning, working memory, and abstract thought. Another unique feature was the prominent omega sign, or hand knob, in his primary motor cortex, particularly on the left side. This area is associated with fine motor control, especially of the hand, and might correlate with his lifelong passion for playing the violin. His parietal lobes, crucial for spatial reasoning and mathematical thought, were also found to be significantly larger and more symmetrical than average. Furthermore, the corpus callosum, the bridge connecting the two hemispheres, exhibited an unusually high density of nerve fibers. This increased connectivity could have facilitated faster and more efficient communication between different brain regions, contributing to his holistic thinking. Studies also revealed a higher-than-average number of glial cells, which support neurons in certain areas, particularly Brodmann Area 39. This region is associated with language, spatial cognition, and abstract reasoning, all hallmarks of Einstein's genius. Beyond these structural differences, Einstein's thinking style was famously visual and intuitive, often described as thought experiments. He imagined himself riding on a beam of light or observing clocks from different frames of reference, leading to his groundbreaking theories. His ability to visualize complex problems and connect seemingly disparate ideas was a cornerstone of his scientific breakthroughs. Ultimately, the study of Einstein's brain underscores the concept of neuroplasticity, the brain's ability to adapt and reorganize itself. While his brain had unique features, it also reminds us that genius is not solely predetermined, but can be shaped by intense intellectual engagement and unique ways of thinking. Einstein's legacy continues to inspire us to question, explore, and push the boundaries of human understanding.